in the Cretaceous at the surface. And this water here, when you look at it, it's crystal clear and pure. It's the same thing like we had down at Springwater. The spring's about 7 kilometers this way. It's coming from the head of the aquifer, just like the South Concho was. The same aquifer, same water signature, and so, you know, it's just an interesting place to come to study. What you see is like these rocks here, kind of like all the frogs.
Regulated by what's called the Clean Water Act, and then public water supplies, like municipal water supplies, are regulated under what's called the Safe Drinking Water Act. So if you have a house out in the country and you have your own well, the government doesn't regulate that well. I mean, unless you choose to dump something bad down it, in which case you're violating a different law. But the government doesn't require that you test the water in your well. It's a good idea, but it's not required. Whereas if it's a community water supply, whether it's publicly owned or privately owned, federal regulations say you have to test that water supply at least once a year for a whole list of different naturally occurring and synthetic compounds, synthetic organic compounds, major ions, minor ions, and metals, and they stipulate, not for all of them, because not all of them have health effects, but for the ones that have health effects or that have kind of, we say, aesthetic qualities, like salinity, for example. Salinity won't kill you, people just won't drink water that's too saline because it doesn't taste good. So there are regulations about the levels, the concentrations of different constituents. And so for a small community like this, it is easier for them, simpler for them to put in a well and get their water from a well, because well water is generally cleaner, not always, but generally. They still have to test it and to make sure that it meets the regulatory standards. And if they were pumping surface water, they would have to treat the surface water for bacteria and a lot of other connected to this creek, even though this creek is relatively clean compared to others.
You just shock it with fluoride. It comes out of a well, you just treat it with a little chlorine and it's good to go. Where if it comes out of here, you would have to then, treat it with this surface water treatment facility to take all the suspended solids
and
out,
settle and filter, and then you'd have to chlorinate it anyway.
But this is a real famous area. I don't know if y'all read in what I put together for you in that second part of your guidebook. This was the area that y'all heard of, like a gentleman by the name of Goodnight, or in American history or Texas history.
I sincerely doubt that.
This was where the large North American cattle drives came. And so in Texas history, when it started, there were just these massive herds of wild cattle all over this area, and they were free for the taking. And so y'all watch the car. So like what would happen is these guys would round them up down here, and all the population lived up north, to the northeast. And they, like in a place like Kansas City, they actually had a railroad track to it. And so they would take these herds of cattle, like, upwards 500 to 1,500 cattle in a group, maybe even up to 3,000 cattle in a group. And they would herd them with horses all the way to Kansas. We're talking 1,800 miles, about 2,200 kilometers with horses. And so, and then what they did is they followed these water systems. And because of the water was typically, there was a lot of conflicts occurred in this area over here. So just north of here on the Middle Concho River, that's where the Native Americans in this region had a really strong hold around these water supplies. And when you started having immigrants from Europe, like guys like me, they hit hard. And so there was over the water, and so there was a lot of bloodshed over these water sources because they had to have them for life. We wanted them as new people coming in, they wanted them for agriculture and things of that nature. You know, the folks that were here didn't quite understand that, I guess. So it's a bad deal, guidebook. But you can meet first part of next week. That's one of the most historic ports where the U.S. Army was stationed, and it was on these water supplies. All these ports that are established throughout this region are by water sources, and that's because they tried to kind of control or eradicate the Native American populations by putting these forts in specific areas. So when we go there, it's really the way the American culture in Texas has been shaped is right here. It changed it all.
I guess it was kind of like it was fighting in Roxton. There was acculturation, and people were absorbed into the conquering peoples. But here, I don't know how much assimilation there was. The Comanches were basically exterminated, right? I mean, a lot of the Native Americans now live on what are called reservations, which are set apart land specifically for Native Americans. But all of North America, all of the Western Hemisphere was occupied by other people before the European settlers came. And, they were basically militarily and culturally overwhelmed over a period of about 400 years.
It took a long time, though, because like the Native Americans were supreme horsemen. And so once
And again, the Spanish introduced the horses. The horses weren't here before, but the Native Americans learned really quickly and got really good at horses.
Really good. Like, I mean, they could launch arrows and things all from horseback running at speeds of 30 kilometers an hour. They were gifted. And so they were far supreme to the American Army when it came to military combat.
It was guerrilla raids, basically.
They were outhorsed by gunpowder. The repeating rifle that was invented here, that's kind of what started.
And the Native Americans, as time progressed, had access to firearms also, but they were fighting an army.
And there's a guy the area I came from, I almost did a PhD in folklore. It's like storytelling, and I'm fascinated by stories, and growing up in this area, every little stream has a story, every little mountain has a story, things and all the solids landing in the river. Here we don't see any of that. This is a pristine system.
So is this going to be like a reference reach for you compared to some of the other stuff?
That's what we use it for. It's the place to kind of come show like what a place should look like if it's natural and working and functioning.
I'm wondering, after Cristobal this afternoon, if we take measurements here and take measurements at Cristobal, if we ought to go back to where we were gauging yesterday, just to measure electrical conductivity and, EH and dissolved, or
we can do it on
dissolved
the way
oxygen. Exactly. Just so they get a sense of how impacted that is at an urban site compared to these.
Yeah.
So I predict electrical conductivity is going way up. Now, part of that's probably because they've got saline inflows elsewhere impacking it.
Well, it's been evaporated too out of those lakes.
Yeah,
Evaporation impacted. What do you say? Let's get Garrett, you want to go get the truck?
So I'm going to set my knife down and be careful nobody step on my knife. All right, where is bottle number 1? Okay, 13. So what I'm going to do, find a steady place to hold this. All right, I'm going to take out the glass stopper, and as quickly and neatly as possible, I pour in these two reagents. And you'll see that, remember I said it gets orange, it starts to change color. I trapped a little bubble. Damn it.
Sometimes if you take that and drop it straight down, then it can.
Yeah, exactly. Sometimes you'll entrap a small bubble of air in here, and it's difficult to avoid. So anyway, you can see that I am mixing this back and forth, back and forth. I'm agitating it to dissolve the reagents. And so once I've done that, I'll let that settle for a minute or so. And
They say sometimes the rule of thumb to shake these is 60 times, so you can sit here and at least get them shook up.
that's hardcore. What did I get on my shirt? Oh man, did I get reagent on my shirt? I bet I
Probably
did, too.
so.
That's why you want to wear old shirts when you're doing field chemistry. Oh well, I've got an acid hole
See
in
them
it.
starting to kind of lock up in there.
Yeah, and the idea is once you've turned it some and then let it settle, then it should settle out so that you get the clear liquid on top and it's starting to, the precipitate settles at the bottom. Yep, that's my manganese, all right.
Yeah, is the air bubble going to affect any of the results?
Maybe a little bit. I tend not to worry about it.
Okay.
Phil would probably slap me for that.
There's
But
nothing. There's going to be some air bubbles.
yeah,
It's hard to get
you
it
just, some of it's, you just do the best you can.
Okay.
After you do about 500 of them, you probably get pretty solid.
Yeah.
Like anything else, practice.
All right, so if you look carefully, you can see that it's starting to settle out, so that's probably pretty good. There's still some precipitate on the bottom. Like I said, the amount that you're adding is usually in excess of, is more than what you need. And so not all of it will dissolve. So now what I'm going to do is add the sulfamic acid powder pillow. So I'll cut this open. Careful.
This is third reagent.
Third reagent, that's correct. In fact, we use 5 reagents in this particular titration. So the sulfamic acid powder pillow, again, you need to make sure that you're adding the correct reagent in the correct sequence. So this one is kind of short and fat, and again, I'm going to cut it open. Helps to have a rock here to cut on. Where I work, it's usually nothing but dirt. All right, and then I open it up, and then I add this, and cap it again quickly, and voila, I lost my air bubble because I've added more mass to it. So, what do you think's going to happen?
Another color.
I think it's turn it brown.
Color is removed.
Color actually will not change. Well, it will change some, but it's not going to go away, not yet. But look, you're dissolving the flock. You're adding acid to it. It makes sense that it, you could dissolve away the compound. Right. So, and it's gotten really dark. So sometimes, yeah, this is where doing it 60 times is probably a good idea. Because, yeah, and again, you may not dissolve all of the reagent, but you see this stuff that was stuck to the bottom? It's gone now. So that's dissolved away when you add the acid. And if you look at the color, this is a really dark orange, which indicates there's a lot of dissolved oxygen in it. Gas solubility is a function of temperature. If we were doing this work because we're doing surface water rather than groundwater temperature doesn't vary much year-round. Surface water temperature does. If I did this in the wintertime, when air temperature was 0 to 5 degrees Celsius, is that a frac truck?
Water truck.
0 to 5 degrees Celsius, this would be even darker. Because the colder the water, the more dissolved oxygen it can hold. Right now, we didn't get an outside air temperature measurement. Did you guys grab one off the YSI before you put it in the stream?
I don't know.
I forgot to do that. Normally it's helpful to do air temperature as well, but I'm guessing air temperature right now is probably maybe 30 Celsius.
Is there a thermometer in there? Boys normally have a thermometer.
I've got a digital thermometer in here, but I left the probe back in the bus.
It may not be.
That's
That's all right. It must have
What's that?
we may.
You can turn that on. Well, you have to let it dry.
Exactly, yeah.
Acceleration for... Oh, yeah, we're speeding up the... yes. If you look now, though, there's still a little bit of stuff you can see floating, but it's pretty clear.
But it's pure.
Yeah, well, pure is a relative term,
Yeah,
but yeah,
yeah.
it doesn't have much suspended matter floating in it,
Yeah.
not that it's visible to the eye anyway. So that's sample number 1. So I need a volunteer. Mary me will get a chance to do this, but I'm going to get you to keep filming right now. Okay. I have to remind myself, I have to talk to myself as I'm doing this, just to make sure that I don't forget the sequence.
Make sure you tap that pillow.
Yeah, you want to, if you tap it, that means, if it's like this, then you may have stuff stuck in one corner, so you kind of tap the pillow like this to get it in there. Okay? And then if you look, that's starting, give that another minute or so. That's starting to settle down. And somebody can, it's like having a baby. You get to cut the umbilical cord.
That's funny.
Okay, so that's probably good enough. Let's go ahead and cut that off. I'll try and catch it while it goes flying. Actually, oh, there it went. Okay, what I was going to say is sometimes what I do, and you can get too cute with this and then you spill it out, and that's not good. is I try and cut it most of the way, and then I'll just pick up the leftovers. Okay, so take the cap out. Okay, there's a little bubble. Don't worry about it. Okay, so that's it. Now you just mix that. James said 60 times. I would say mix until clear. Once, and you don't have to mix it quickly. You can just, like twice per second or something like that. Just nice, easy rotating motion.
I was one of these lab trained.
Like you're waving to the king, just kind of like.
Trish used to get mad at me because we get into these great arguments about sampling methods.
Or like
and
saying
things.
bye-bye.
People are very particular about their ways.
Mulligan said that he and one of the other guys at the Bureau, when they were out working, didn't get the gauge. We're going to set up the measuring tape and, somebody lost it.
There you go, thank you.
And we're going to gauge not too long, and then we'll go over to where we were yesterday. We'll get out of the sun, we'll eat lunch, do the titrations, and then we'll do some more water finishing.
That would be for to preserve. Do you use HCl to preserve your cations or nitric?
Nitric. And I think the reason why is that 6 months, I think, is what they specify. And again, 6 months.
صفقة واحدة 0.143
ها؟ زيرو؟
لا لا بلازم
Lost the other.
0.00125. And so this dial dispenses the liquid. Actually, this should re-zero it. Yeah, this dispenses the liquid, this re-zeros it. So you want to have it start at 0. So 0.2 normal sodium thiosulfate, and I already had one open, I think. Should be in here. No, I got a straw. Thanks, man. I actually ordered some more because the ones I had looked a little bit sketchy. Big hole here. That's not good. Okay, so you have this straw. Take the straw out.
No, it's in the black case.
All right, take out a straw. I said there were 4 reagents, or 5 reagents rather. The first 3 were the ones we used here: the alkaline iodide azide, the manganese sulfate, and the sulfamic acid. The next is the sodium thiosulfate. So I'm going to take the cap off here. I'm going to stick this down in here. I probably ought to rinse it off first with distilled water. Yep, that's a good idea. So James is doing the same thing. So I'll rinse this with distilled water. Paper towels? I had paper towels somewhere. John, did you get those on? Oh, I had some on top too, I thought. So, yep, thank you. Okay. So I'm just going to, ideally, if you're not doing a field measurement, if you're doing a measurement in the lab, you don't want to just, rinse it with distilled water and do it again. But for field purposes, this is going to be okay. So I stick the straw down in here. I put this inside, snap it into the digital titrator here, like that. And then I push the piston. And the piston should lock up with this
Straight up.
right here. And so what I'm going to start doing is I'm going to start dialing this, and over time, slowly, it should displace the bubble that you see at the top. And sometimes you just kind of help it along. Excuse me. And you do like this. You just push it. Yep, there it is. So I still got the bubble.
What's the solution inside?
0.02. I'm sorry. I had too many zeros. 0.2000 sodium thiosulfate. So here's another one. We can pass this around and you can see it. Write it down if you want to.
You guys make sure that everything we do winds up in your book. Like tonight, y'all get together like where they have.
Yeah, after we get back, I think what I want to do is get the results from yesterday and today and make sure everybody's got all the results in the books, because you're going to be working with them. So here, ideally I should be wearing gloves. I don't have my gloves on right now. So I'm drawing this up and you can see the bubble is going away.
So, you know, good practice says I should wash my hands off. All right, so I have now displaced the liquid out, and this auto titrator is reading 0332, or not auto titrator, digital titrator. So I want to reset it back to 0. I re-zero it. I've got no liquid coming out the top. Okay, so I take my sample, and our waste bottle is here, excuse me, and I rinse the sample in the graduated cylinder. So I'm just going to put a little bit in, rinse it out.
And you see what he did here, where he turned this upside down?
I don't want dirt.
It's always the way you do it.
So I'm rinsing it like this. I'm trying to rinse this as much as possible, and then I pour it into the waste bottle. And I'll have a little residual liquid, not much. At the scale of this graduated cylinder, that's fine. So I'll pour this, and remember how to read a graduated cylinder. You look at the meniscus, the curve, and where it intersects the line. And again, being an American geologist, we're mixing units. So here we're using metric. This is in milliliters. So 100 milliliters. And does that look, I realize I'm on a surface actually, yeah, like that. Is that pretty much straight on? Does that look good? Let's try this. Yeah. Is that 100 milliliters? Pretty much. Do I need another milliliter? No, I think that's okay. Alright, so I've got 100 milliliters. So I put my stopper back in, because occasionally you'll have to retitrate. You mess up your titration. My experience has been when you retitrate, you typically don't get exactly the same value, perhaps because you've now got headspace in. But put it back in case you need to redo it. Alright, we have rinsed this out with distilled water. You already did that, James?
Yes, sir.
Okay, I'm going to rinse it again a little bit with, actually, skip that. What I'm going to do is what I do instead. I will dry this out. Again, this is not perfect laboratory technique, but for field purposes it's okay.
Normally,
You just
like,
want to have gloves on.
normally I carry plastic polypropylene beakers too.
Yeah, and yeah, often you want to have gloves on. You want to, I use like tissue instead of paper towel, but this is what I have. So I will pour this out, and so I should have 100 milliliters. Note it says 100 milliliters on here too, but this is approximate. The graduated cylinder is more precise. Sometimes on a graduated cylinder like this one you will see TC/TD. In English that means to contain or to deliver. So what that means is that it contains 100 milliliters where we poured it, or whatever value on here, but it also delivers that back out. That's at 20 degrees Celsius, which is close enough.
And then since before that dries out, we normally go ahead, because
Yep.
we're going to have to use
There you go.
it
Yep.
multiple
Exactly.
times. Take your distilled water. and-
Okay, now what I'm going to do is put this, you normally put it on a light colored piece of paper like white paper. You don't want to put it on a good piece of paper though, because this will stain. And now I take the starch indicator solution. So this is our 5th reagent. No, I'm sorry, this is our 4th reagent. The sodium thiosulfate is the 5th reagent. And I squeeze this, and basically you're just adding to excess. So I tend not to worry too much about the gradations here, but we're a little bit above 1 milliliter. So typically I will put in 2 droppers full of the starch solution, and note the color change. All of a sudden it gets very dark, like I said, inky blue. And then I stir with this. And so the color, oops, yeah, it goes away. And so then I start to titrate. And I know from previous experience, like I said, that surface water tends to have about 8 milligrams per liter. And this is, each of these digits represents 0.00125 milliliters. The conversion here is, let me think about this for a second. So 200 is 4 milligrams per liter. So it's, you multiply by 800, 0.1 is going to be 40.02 to get the conversion. So if I know that I'm looking at about 800, I can just start whaling on this. That's colloquial English.
Another way you can do it, if there's two of you, a lot of times, like, we'll do these together, and while Alan runs that, I'll keep this just kind of.
And I use this as a stir stick. You can use a magnetic stirrer. You see, I've just added 100 digits worth. Color hasn't changed at all. Nothing's happened. So,
The stir bars. Yeah.
so yeah, I didn't bring a stir bar or magnetic stirrer with me. For alkalinity titrations, I like to use the stir bar and the magnetic stirrer, but for these, this is fine. So I'm up to 200. Again, like with colorimetric pH titrations, you don't want to over-titrate.
What's
And this
the
has got
color?
lots of floaties in it.
What's
what's
the amount of sodium thiosulfate you added to the solution? The sample.
It's varying. It's not constant. So the amount I've added so far is 200 times 0.00125. Don't worry about writing that down yet. Write down the final number.
Okay.
All right, so I'm going to go to 300. Actually, maybe to 255. See if it gets any lighter. I don't know, it's starting to get a little bit lighter. It should get to a paler blue. So let's try, bless you, 300. So I'm going to play with this. Again, you don't want to over-titrate it. Alright, so it's very slowly getting pale. So let's try 350. So note that I was doing it in increments of 100 to begin with. And again, that's specific to this type of titrator. And now, the last several times I've been doing units of about 50. Now it's getting paler, slowly. I'm not sure why there's all this suspended matter in it. That happens occasionally. That may be because it's an unfiltered sample. Okay, so because the color's getting paler, I'm going to reduce the number of digits now. So I'm going to go from adding 50 digits at a time to adding 25. So I'm now at about, that didn't sound good, 375. And it's getting paler still. So let's go, I'll go to 20 now. Let's see, so 395. Now, do you see how the color is lightening here?
Yes.
All right. So from here, I'll probably go to maybe 15. So 410. Now it's getting very pale. So it's possible to over-titrate this, and if you over-titrate, then you don't know what your value is, just like if you over-titrate for pH dishes now. So I went from 410 to 415. Still getting pale. I'll do another 5. So I'm going to 420. Paler still. John, have you done Winkler titrations?
I haven't done one of these, no.
We did them all the time out in the field for my studies at Big Bend and things. It works very well.
I asked Warren Wood, who wrote the USGS manual back in the 1970s, and Warren said this is the way to go. Mind you, he's now retired, so
Yep.
you know he's an older guy, but
we use meters to do DO, and then we also use the field spectrophotometer.
Yeah. and field spectrophotometer works fine too.
My guess is this would be more accurate because you're titrating.
Well, again, you are titrating, but also it's exposed to the atmosphere, and so if I leave this out long enough, the color will get darker again because it will uptake atmospheric oxygen. So you have to titrate relatively quickly. All right, so I'm at 425. I'm going to go to 3 digits now, so I'll go to 428, let's say.
These are how I did our DO measurements in Kentucky.
Yep. It's
And we found it relatively comparative with the meters.
yeah, it's pretty dependable. So I'm now at 430. I've gone to 2 digits.
Titration till colorless?
What's that?
Titration till colorless.
Until colorless, exactly. And you know, colorless is partly the eye of the beholder. You have to, which is why I have it on pale paper. Usually even white paper. Okay, so I've gone to 432. Now I'm going to start doing 1 digit at a time. So 0.00125. So I'm at 433, 434, 435, getting there, 436, 437. It's more exciting when you're doing it yourself than when you're watching somebody else titrate.
Oh no, it's pretty exciting.
Woohoo! 438.
Yeah, it's still exciting.
Still a little bit of color. 439. Actually, you know what? Move this book. Because sometimes if you've got something that's blue next to it, you can see it. Okay. Now, do you think that's colorless at this point? Looks pretty colorless to me. So, let me go one more just to see if it changes anymore. I don't think it made any difference. So that was 439. Remember I said multiply by 0.02. Remember what I said I thought the dissolved oxygen would be?
Yes, it's about 8.
About 8. So it's a little higher than what I was expecting, but not a lot. I suspect that the other measurements we get will be close to this because the conditions were similar, but we can't be sure.
Yes.
So,
4.39 is the number from that micro.
439. I went to 440.
What's the number of clicks?
That's the number of clicks.
Yes.
Each click corresponds
Each
to
click corresponds to 0.00125. Here, let me pull out my phone. I'll do my math.
0.01.
25. Okay, so thanks, Dr. Ward.
You're welcome, sir.
All right, so
أنا مش عارفة محمد.
Number of
calculator
digits times
0.00125 times 439 equals, no, divided by, stupid, sorry. Is that right? I did 439 times 0.00125. No, that's not right. It says...
the number of milliliters of titrant added, right?
Yeah, exactly. That's the number of milliliters of titrant added. The conversion ultimately
There's another
is...
step.
Yeah, that's right. I'm missing another step. You multiply by 0.02 ultimately.
Right.
And I have to go back and calculate the other step. I've got it written down
It
somewhere
says the
here.
digits here.
0.2.
Digits times 0.01 equals milligrams per liter DO for 200 mils.
0.2.
Yeah, that's it. It's the 200 mil
So
part.
you used 100 mils, therefore it'd be 0.02
Right.
times the digits.
0.02 times, yeah, times 439.
0.0.
Yeah, 8.78. So that's what I had. So I was multiplying by the number of milliliters, which is not, there's an additional step that I was missing. So recognize that for dissolved oxygen, to do the conversion, you multiply by 0.02 times the number of digits on the titrator. Okay. 8.78. So
So if you
Next
want
steps.
equivalencies, you use
Yeah,
this.
you have to use
Straw?
No, you use the same cartridge. You just rinse it off. Yeah, well, yeah, I even use the same straw. I just rinse off the straw, so I just
So you used 100.
0.02. So there you go. All right, so I'm going to pour this off. Watch what happens to the color here. Oh, all of a sudden it gets blue again. So, okay.
All right. Yeah.
And
All
then
right,
you do the
so
same thing
all we do
with
now
carbonate.
is rinse this out,
Normality acid.
wipe it out,
We use
rinse this off, blot it, rinse this out with distilled water. Oh, this is a neat trick. This, yeah. So you rinse this out, and then you wad up paper and sort of push it down with that, and then you get to go like this
to get it
until
out.
the paper towel comes out. And occasionally you have to sort of fish around with that thing and pull it out. So anyway, the first, at some point you're going to have to re-zero this. You don't want to leave it where it was. You set it back to 0. So remember, the way you do that is other way. Yeah, the way you do that is like this. I'm pulling it away from me. And it sets to 0. I usually don't do that step until I'm ready to start the next titration, just because occasionally I'll get stupid and I'll forget to have written down the number from the previous one. And so it's important to, you know, leave it so you can go back and reference it again in case you forgot to write it down. But at some point you've got to re-zero and start the next one. So that's it. So you can see there's a little bubble in here. And so what I'll typically do after I re-zero, or if I remember before I re-zero, is I'll turn this just so slightly and then I'm at 0.002, so I got to reset it again. But you don't want a bubble in the line or in here, and you want this at 0 before you start your next titration. So James has got